Okay, so tell to your friend, fastly join this class. We are going to start. So this today's lecture is concerned with the heterocyclic compound. So before starting this lecture, I would like to ask you what you know about the heterocyclic compound. Hello? Hello? Hello?
हॅलो सर.
हा, आवाज येत आहे ना? हा, हेटेरोसायक्लिक कंपाऊंड बद्दल काय माहिती आहे तुम्हाला? कोणी सांगेल? यस, बोला रे मुलांनो. हॅलो? हॅलो? आवाज येतो रे?
Yes, sir.
हा, तर मी काय विचारतोय तुम्हाला, हेटेरोसायक्लिक कंपाऊंड बद्दल काय माहिती आहे? कधी ऐकलंय हेटेरोसायक्लिक कंपाऊंड ना? हॅलो? ओके, सो हेटेरोसायक्लिक कंपाऊंड तुम्हाला सगळं माहिती आहे, तुम्ही सांगत नाही आहे ना? ओके, असू द्या, मीच सांगतो तुम्हाला काय आहे ते. ठीक आहे. सो heterocyclic compound, it is one of the important class in organic chemistry because it has so many application in various fields of sciences, in pharmaceutical, in industrial. Okay, so that's why it is very much important to study this class, heterocyclic compound, because before that we learned so many compound, they having only carbon and hydrogen. Okay, so hydrocarbon compound we are studied, but there are some new class it come out due to the inserting new or other than carbon atom or heteroatom like the nitrogen, oxygen and sulfur in the hydrocarbon molecule, and it form the cyclic compound, or it may be cyclic or non-cyclic compound, but they are having the other than carbon like a nitrogen, oxygen and sulfur. Okay, so these are elements, this atom, nitrogen, sulfur and oxygen is called as heteroatoms. Okay, so if the compound having the hydrocarbons along with the nitrogen, oxygen or sulfur, any of the one or any number of heteroatom in the molecule, so this type of molecule is considered as the heterocyclic, hetero heterocyclic, because there is cyclic word is there. Cyclic means the cyclic compound is there. Okay, so cycle of cycle of hydrocarbon, we know their example is the benzene, naphthalene, anthracene. So many is there. So in which that one of the carbon is replaced by one or more carbon is replaced by nitrogen, oxygen, and sulfur. Okay, and it gives new compound. There is a heterocyclic compound. Okay, so let's begin. What is the heterocyclic compound and so many things about this? So we are going to be start with this some molecules. Okay, firstly we are seeing some basically come in this family, heterocyclic compound. So now we see here heterocyclic compound are the cyclic compound with an element other than the carbon. Okay, then aromatic heterocyclic compound, you know that very well. There are some molecules there. This is the pyridine. Okay, this is the pyrrole, furan and thiophene. Okay, if you see the benzene molecule, in benzene molecule there are 6 carbon, there are 6 carbon, and there is no presence of heteroatom. There is no nitrogen, there is no oxygen, no sulfur. So there is simple carbon and hydrogen bond, and it is present in a cyclic form. So it is a hydrocarbon cycle, and basically their name is benzene. Okay. But what happened? In benzene, the one of the carbon, okay, this is the benzene, 6 carbon, okay, and there is a alternate single and double bond, and all are the carbon and hydrogen bond only, okay. But here one of the carbon, any one carbon from the benzene, or anyone any number of carbon from the benzene, 1 2 3, is replaced by any heteroatom, nitrogen, oxygen and sulfur. So it convert into the this type of molecules, and these are the hetero molecules. These all are the aromatic in nature. These all are the aromatic in nature. So that's why it is called as a aromatic heterocyclic compound. Okay. So in pyridine, we see here there is a nitrogen is inserted in between two carbon bond. Okay. So one of the carbon from benzene is replaced by the nitrogen, and that's why the structure is known as to be the pyridine. Okay. And this pyridine is also aromatic in nature like benzene ring. Okay. Because there is a delocalization of 3-5 bond. Okay. Likewise to benzene, this pyridine also shows delocalization of 6-5 electron through the 3-5 bond. Okay. So that's why it follows the Huckel's rule, and it is behave like a aromatic ring. Okay. But there is presence of nitrogen rather than the carbon. So this structure is known as the aromatic heterocyclic compound. Okay. And their name is pyridine. Next one is here is a pyrrole. 5-member ring is there. Okay. 5-member. Before that, we know the hydrocarbon, 5-member ring hydrocarbon is a cyclopentadiene, you know. Okay. It is a non-aromatic, but there is one negative charge on this 5th carbon. This structure become to be aromatic. Okay. Cyclopentadiene anion. Okay. So there is negative charge means 2 electron, and this 2 pi bond. So total 6 pi electron in delocalization, and it behave like aromatic in aromatic compound. Okay. But in heterocyclic compound, the one of the carbon from the cyclopentadiene anion is replaced by nitrogen. Okay, means if you replace this carbon, okay, this carbon you replace by the nitrogen, by the oxygen, and by the sulfur, and you will get the 3 different heterocyclic molecules. Their name as pyrrole, furan, and thiophene respectively. Okay. So this 3 structure are the 5-member ring is there. Okay. And there is a conjugation of 2 pi bond along with their 1 lone pair electron by or having hetero atom. Okay. So there is a 2 pi bond in a conjugation, and along with there is one heteroatom is there, and which carry the lone pair of electron, non-bonding electron, and this non-bonding electron in the delocalization of this 2 pi bond, and that's why there is a 6 pi electron is delocalized inside this ring, and that's why this ring become to be aromatic in nature. Okay. So these are the heterocyclic compound. They behave like aromatic in nature. They behave aromatically due to the delocalization of 5 bond electron, 6 pi bond electron, or follow the Huckel's rule, simply we can say. Okay. So these are the basic some molecules about the heterocyclic compounds. Okay. You here you just have to understand, you replace or you insert one or more heteroatom like nitrogen, oxygen, and sulfur in benzene or into the cyclopentadiene. Okay. So you will get the new molecule along with the heteroatom. So that's why it is called as heterocyclic compound. And these are heterocyclic compounds, they also follow the Huckel's rule like benzene and cyclopentadiene anion. So that's why they are called as aromatic heterocyclic compound. Okay. Next. Now we learn in the second year, fourth semester, hydrocarbon, okay, glucose molecule. So in which that we are studied these two class. One is furan and one is pyrrole. Okay, so furan and pyrrole is there, so that indicate furan means 5-member ring, and here pyrrole means there is a 6-member ring. So in that ring there are 4 carbon and 1 heteroatom is there. So this is to be the furan structure. Okay. Similarly, here the pyrrole is there. Pyrrole means 6-member ring, and in which that there is a heteroatom. Okay. Heterocyclic compounds again, if it contains more than one heteroatom. So here imidazole, okay, like a pyrrole. Okay, in pyrrole there is only one nitrogen atom and 4 are the other carbon and hydrogen is there. Okay, so it form the aromatic structure also, and it is simply called as a pyrrole molecule. But if you replace the another carbon by the nitrogen, means if you insert the 2 nitrogen in the cyclopentadiene, so you will get the imidazole structure. So in which that you can see here there are 2 heteroatom, 2 nitrogen atom present in this ring, and this ring also present in aromatic in nature because of 6 pi electron into the delocalization. Okay, there is 6 pi electron in imidazole. Okay, so that is the 2 electron from this nitrogen are involved into the delocalization with the another pi bond. Okay, and due to that 6 electron delocalized inside the ring. Okay, and this nitrogen they are having lone pair of electron, but it is not contribute this lone pair of electron into the delocalization. It is free for donation. Okay, so that's why it behave like a basic molecule. Okay, then another is here oxarine. Oxarine, this is the 6-member ring. The 6-member ring, there is a carbon, hydrogen, also oxygen is there, also nitrogen is there, means it contain the more than one heterocyclic heteroatom. Okay, and also it behave like a aromatic compound because of 6 pi electron in delocalization. But this molecule having 2 heteroatom, and it is also the example of heterocyclic compound. Okay, it is the oxarine. Then oxathiazine means thiazine means there is the addition of sulfur is there. Okay, means 3 heteroatom, oxygen, sulfur, nitrogen. So there is all heteroatoms are there. Okay, oxygen, sulfur, nitrogen, 3 heteroatom in this ring. Okay, so this is the oxathiazine. Okay, let's see here. This is the oxazole. Okay, this is the imidazole and this is the oxazole. There is the one oxygen and one nitrogen as a heteroatom in the ring, and this ring is aromatic in nature. So it is also the example of heterocyclic compound which contain more than one heteroatom. Okay, there is again number of heterocyclic compound is there, 3-member, 4-member, 6-member, and so many number of heterocyclic ring is there, and their example you can see here. Okay, it starts from the 3-member ring. There is a cyclic ether. It is also heterocyclic compound because there is a carbon and oxygen is there. Oxygen as a heteroatom is in this ring. So this is called as the heterocyclic ring compound example. It is very known to you. Okay. Then second one is a ethylamine. Ethylamine, cycloethylamine is there. Okay, means nitrogen in a 3-member ring. Okay, and 2 carbon. It's also heterocyclic compound. Then trimethylene oxine. The 4-member ring is there. Okay, and it is also a heterocyclic ring. Okay, it is not aromatic, but it is a heterocyclic because it contains the carbon and oxygen as a heteroatom. Okay, next is the furan. We already discussed. Then tetrahydrofuran. Tetrahydrofuran means reduction of the furan. It will be converted into the tetrahydro. Okay, means addition of hydrogen on this double bond, and then double bond is converted into the alkane, means single bond is there due to the addition of hydrogen. Okay, so there is a 4 hydrogen added, so that's why it is called as a tetra means 4 tetrahydrofuran. Okay, then thiophene, there is a sulfur in a conjugation with the double bond in a cyclic form. Okay, so there is double bond and there is also double bond, and on the sulfur there is lone pair of electron that involve in the delocalization, and it is act as to be heterocyclic compound because it contains the sulfur as a heteroatom. ओके, माझा आवाज येतोय रे सगळ्यांना?
Yes, sir.
ओके, हे समजत आहे, दिसत आहे का स्क्रीन?
Yes, sir.
ओके, काही डिफिकल्टी असेल तर विचारायचं मधात. झोपून नका राहू फक्त. Then pyrrole, this is already discussed. Then pyrrolidine. Okay, means there is a reduction of this pyrrole. Okay, so double bond is converted into the single bond only, and 4 hydrogen is added there, so it is called as a pyrrolidine. Then pyran, then pyridine, piperidine. Okay, imidazole. Okay, so many example is there, and you can see also on an internet on by using a different reference book. You can also see the different example they having the heterocyclic compound, and you can be study. Okay, and if you have difficulty, you can ask me anytime. The next some class of the heterocyclic compound is a fused ring heterocyclic amines. These are the example of heterocyclic compound. Okay, so here we know that the RNA and DNA. Okay, in RNA and DNA, you know the pyrimidine and purine. Okay, purine and pyrimidine. So these are the also heterocyclic compound. If you see their structure, you will see there is a nitrogen and some other heteroatom is there. Okay, and cyclic form is there, so it is called as a heterocyclic compound. Then porphyrin ring, you know very well porphyrin ring structure because heterocyclic compound you already studied. Okay, and with that you studied about the hemoglobin, you studied about the chlorophyll. Okay, so if you see the structure of chlorophyll and hemoglobin, you will see there is a different 4 pyrrole ring is interconnected to each other and form the ring. Okay, so 4 pyrrole ring is there, means it is a heterocyclic compound, but it is the porphyrin ring, their name, specific name for that. Okay, so this is the also example of the heterocyclic compound. Then hemoglobin, myoglobin. Okay, so there where you can see the porphyrin ring is there, and porphyrin ring is formed by the heterocyclic compound as a pyrrole. So this 4 pyrrole ring is interconnected and in a conjugation manner. Okay, and other substituent is also there, but this 4 pyrrole ring form, that ring is known as the porphyrin ring. Okay, and that ring you will see in the hemoglobin, myoglobin, chlorophyll. And next some alkaloid is there. Okay, that's cocaine, nicotine, quinine, morphine, heroin, and LCD. So in this molecule, you can see the structure is there, and in every structure, every molecule, you will see there is a heteroatom inside inserted into the ring along with the carbon and hydrogen. So you can also consider these are the example of heterocyclic compound. So you can see these are the alkaloid compound, these are the porphyrin ring, these are the nucleotide, pyrimidine and purine is present into the DNA, RNA. So these are the different uh, application. You can say it is the application of this heterocyclic compound. Okay. Naming to the amine heterocyclic compound. How to give the naming? So compound in which nitrogen atom occur as a part of the ring, it is called as a heterocyclic amine. Each different heterocyclic ring system has its own parent name. ओके, तुम्ही जर बघितलं इथे आपण ज्या काही इथे रिंग पाहतोय या प्रत्येक रिंगला एक कॉमन नेम आहे. जसे ही पहिली रिंग बघितली आपण. इट कंटेन द नायट्रोजन as a hetero atom and some other are the carbon and hydrogen is there. Okay, so this ring is known as to the pyrimidine. Pyridine. Name is pyridine is there. If there is a 5-member ring and nitrogen is there, so it is called as a pyrrole. Okay, then there are the 10-member ring. Two ring fuse condition. Okay, one benzene and second 3 carbon and 1 nitrogen is there. It is to be the quinone. Okay, so these all are the amine heterocyclic compounds. All are the amine heterocyclic. Imidazole, you can see there are 2 nitrogen. Okay, then indole, there is 1 nitrogen is here on this side. Okay, then pyrimidine, there is a 2 nitrogen in a 6-member ring. Okay, pyrrolidine, there is a nitrogen and 1 4-member carbon hydrogen ring. Then piperidine. Okay, so these all are the heterocyclic amine molecules. Okay, in this chapter we are going to learn about 2 heterocyclic compound. First one is a pyrrole and second one is a pyridine. Okay, so let's begin with the pyrrole. या चॅप्टर मध्ये आपण 2 मॉलिक्यूल स्टडी करणार आहोत. ठीक आहे, फर्स्ट वन आहे पायरॉल आणि दुसरा आहे पिरिडीन. तर आपण पायरॉल पासून स्टार्ट करणार. सो व्हेन वी थिंक अबाउट द पायरॉल, सो पायरॉल इज अ 5-member ring. There are 4 carbon and hydrogen and one is nitrogen with hydrogen. Okay, this type of structure. So here 2 pi bond, 1 nitrogen and 5-member ring. So this is the pyrrole structure. You can see here is the ball stick model structure. Okay, these ball are the carbon. There are 4 carbon is there, and in between to this carbon there is a double bond, and here also double bond in between 2 carbon. Okay, and this nitrogen having the hydrogen. Okay, and singly bonded with this 2 nitrogen atom. This is the pyrrole structure. Basically, pyrrole, pyridine, these are found in coal tar, bone oil, and other product derived from the protein. Okay, so it is firstly introduced by the Rouge. Okay, Rouge is the name of the scientist, and in 1834, it's firstly distillation. Distillation means it's separated, okay, from the coal tar as a pyrrole molecule. Then in 1857, Anderson obtained pure compound from bone oil, distillate and synthesized by the pyrolysis of ammonium mucate, which is commercially used. Okay, so this is some historical background about the pyrrole, and you can be study this historical background by searching the different site and by using the different reference book. But basically we have to be understand about the bonding structure, their molecular structure, uh, their example, their hybridization, their reaction, their property. So that are most important for you as an exam point of view, because the question will be asked on this concept, not on the historical. And historical background study is the important to you have to know how the pyrrole or any molecule it is discovered and they come in front of the world. Okay, so firstly the properties of pyrrole. Okay, if you see the structure of pyrrole, there is a carbon and carbon and carbon hydrogen bond is there. Means hydrocarbon structural part in the pyrrole is the larger part. Okay, and one is the nitrogen bond with the hydrogen and carbon. So this is smaller polar part. Okay, due to the electronegativity difference. So it is a colorless volatile liquid. First thing is there, it is a colorless volatile liquid. So volatile means there is a weak force of attraction in between two molecules. Okay. So due to the less attraction, the molecule go away from to each other, and that's why it is volatile. Okay, but question is here, why it is volatile? So due to this non-polar part in this Pyrrole ring, this non-polar part, okay, this carbon and hydrogen bonding are the non-polar part, and this part is the larger part. Okay, mean non-polar portion of this molecule is more as compared to the polar portion. Okay, so this molecule mostly considered as a non-polar, and that's why this part, due to this part, it is volatile in nature. Its boiling point is 131 degree centigrade and melting point is minus 23 degrees centigrade. It turned brown in the air and gradually resinifies. Only slightly soluble in water, but it is totally miscible with ether and ethanol. Okay, this thing you have to be know, and how this happen due to this non-polar part. Okay, due to the non-polar part, it is not soluble easily into the polar molecule or polar solvent. And you know that water is a polar molecule. Water is a polar molecule. It used as a solvent. Water is a polar solvent, but this pyrrole is a non-polar portion, is a bigger part of this molecule. Okay, means it nearly non-polar molecule, and this H2O is a polar molecule. And you know that solubility law is there, like dissolve like dissolve like. If there is a polar solvent is there and molecule is also polar, so they are mixed to each other and form the uniform solution. Okay, but due to the different polarity, due to the structure, the spiral is a non-polaric structure is more bigger part. So that's why it is not easily soluble into the H2O. Okay, but totally miscible in organic solvent. Organic solvent means other than H2O, if there is a carbon and hydrogen, so and organic molecule used as a solvent. So these are the organic solvent like ether and ethanol. So in that solvent, it can be soluble very easily. Okay. Then pyrrole is a weak basic in nature. This is very much important. It is weak basic because basic means according to the Lewis concept, base is those species they donate the lone pair of electron. Okay. So this is called as to be the base is a base. ओके, म्हणजे जर एखादी स्पेसिस लोन पेअर इलेक्ट्रॉन हे जर डोनेट करत असेल एखाद्या ऍसिडिक स्पेसिसला, इलेक्ट्रोफिलिक स्पेसिसला, तर आपण त्याला काय म्हणतो, बेस म्हणतो. ठीक आहे ना. आता पायरॉल जो आहे तो बेस म्हणून ऍक्ट होईल, पण कसा होतो, वीक बेसिक आहे. वीक बेसिक म्हणजे weakly donate the electron to the electrophilic species. So there is some reason why it weakly donate their electron. So that reason we will be discussing into the next slide. Okay, but you have to keep in your mind this lone pair electron from this nitrogen in a pyrrole, it is engaged with the delocalization with this 2 pi bond in the ring, and that's why it is behave like aromatic compound, aromatic molecule, and there is a less availability of this lone pair electron, and that's why it is a weak basic in nature. But this concept we discuss in detail into the next slide. Then chemical property of pyrrole. Pyrrole is aromatic and more reactive than benzene. Okay, so let us see here. The pyrrole is more basic, more reactive than benzene. Okay, there is reason due to the presence of nitrogen, the reactivity is increases because it is donate their electron, mean driving force for the delocalization of the electron in the ring. It is more, means electron density of this 5-member ring is more than benzene ring. Okay, so that's why the reactivity is also more. It gives electrophilic substitution reactions such as halogenation and nitrogen. Okay, it shows the electrophilic substitution. It also undergoes to the diazotization and dimer reaction, while benzene does not show. Okay, so this is the some properties of pyrrole. Next is the synthesis of pyrrole. There are three synthesis methods given in your syllabus. Okay, preparation of pyrrole as a heterocyclic compound from succinamide, from furan, and by using the acetylene. Okay, so very simple reaction is there given. The succinamide is reduced in presence of the zinc. Okay, so zinc reduce this carbonyl group and convert this molecule into the aromatic due to the forming the double bond in between to this carbon. Okay, so there is simply you can say here reduction is occurred due to presence of zinc. Okay, so that's why it is reduced this succinamide and it convert into the pyrrole ring. Okay, next is here there's the oxygen, and due to the reaction with the ammonia, this oxygen is removed. Okay, and insert the nitrogen inside this ring. Means simply you can say here oxygen is removed. Simply it is a reduction also there. So nitrogen is inserted into this carbon in the ring, and this oxygen is removed and it converted to the pyrrole. Okay, so this is the second method, the preparation of pyrrole from the furan by the reaction with ammonia. Okay, so this is the reaction. Then reaction is a reaction with acetylene molecule, alkyne molecule. There are two alkyne molecule and one ammonia molecule. Means 2:1 reaction is there. Okay, this one molecule and this one molecule means these are the two molecule, and this is the one molecule means 1:2. 1:2 reaction is there, and when it passed through the red hot tube, it convert into the pyrrole compound. Okay, so in this way you can be synthesize pyrrole by using succinamide, by using furan, and by using acetylene. Okay, so now we are going to stop here because our time is going to be end. And in this chapter we are learned so many things. We are going to be learned so many things about the heterocyclic compound and organometallic compound, and that are so much important received in the field of chemistry because it's having so much application, and so much application uh, uh, make it more useful and more attentionable by the various people in the chemistry. So that's why everyone you should have to be understand it very well. And if you have any question concerning to this chapter, concerning to this any topic, you can ask me anytime. But in today's lecture, if you have any question, you can ask me. Hello, I'm audible? Hello.
Yes, sir.
कोणाला काही जर क्वेश्चन असेल, समजत आहे का? फर्स्ट थिंग, आर यू अंडरस्टँड? समजत आहे का रे पुरांनो? हा,
Yes, sir.
हा, ओके. आणि तुम्हाला जर काही क्वेश्चन असेल तर विचार